Hey everybody in Calc BC, welcome to lesson 4.5, polar coordinates and polar graphs. So this whole unit so far, we've been talking about parametric equations and kind of pairing that with vectors. And now we're going to move past that to polar coordinates and polar graphs. This is the last kind of new way to graph something that we're going to learn about this year, and it's in this unit. So as with this whole unit, we've been in unit 9 of College Board's version of the units. And now we're all the way down here in 9.7, defining polar coordinates and differentiating in polar form. We're going to start out just by defining what polar coordinates really means. So think about like with parametrics, we were still on the XY axis or axes, the XY plane, but we were using T kind of in the background to kind of sketch the movement of a particle, right, around a plane. And in polar coordinates, we're still going to be on the XY plane again, but we're going to introduce a brand new way of defining ordered pairs. And so we're going to be talking about derivatives of vector valued functions that can be extended to polar coordinates. And we're going to talk about equations r equals f of theta, but we'll get there. We don't need to think about that right now. But I am going to start us off with the beginning of the 4.5 notes. So let me switch on over to that. All right, so here are our notes for 4.5. As I'm sure you know, rectangular coordinates are always in the form x comma y. Polar coordinates are in the form r comma theta. R meaning a radius and theta meaning an angle. And take a look at this graph here. This is still technically on the XY plane. This right here is really our x-axis, and this right here is our y-axis, but it's helpful for polar coordinates to kind of think about a series of circles, each measuring 1 unit additional in the radius as we go. So this inner circle is going to be kind of intersecting the x-axis at 1 and -1, and the y-axis at 1 and -1. This will be 2, 3, 4, 5, etc. And how we graph a point in polar form is to think about that the 4 is the radius and the 2 pi over 3 is the angle. So the radius first tells us that we're 1, 2, 3, 4 units away from the origin. And then the angle tells us kind of what angle to go at around the circle with a radius of that length. And so since the angle here is 2 pi over 3, I have a radius of 4, and then I'm slanting that around or kind of twisting that around until we get to 2 pi over 3, right? And that's the angle works just like with the unit circle. So we start in the positive x direction, go up for positive, and go down for negative. So wait, let me count that again. 1, 2, 3, 4, to there. So right there we have a point, and I'm going to label that as point A. All right, letter B here is 3 comma 7 pi over 6. So we go to a radius of 3, and then we twist this to 7 pi over 6. And then right there is going to be our point B. Our point C is going to be at -2 comma 5 pi over 4. Okay, so this is kind of weird. So I like to think about that like we're still rotating this way. Hold on, let me think of a good way to say this. Let's think about if this was +2, right? If it was +2, we would go out to here, and then we would twist until we get to 5 pi over 4. And 5 pi over 4 would be, 4 pi over 4, 5 pi over 4 will be right here. But instead of going to +2 in that direction, I'm actually going to go backwards. So I'm still in this direction, but I have an r of -2. So I'm going this way too. So it's actually all the way over here. And that's our point C. And the point D is going to be 2 negative pi over 6. So this time we go this way, and pi over 6 is an angle. It's kind of the opposite of this. So we go to here, and that's going to be point D. All right, so I think the trickiest one is if you have a negative r, and it just kind of means you go backwards through the origin the way that you came to get to the point. okay? So that's kind of how the basics of how this works. That's how you plot points. We have an R and we have a theta. The next step here is then going to be how do we translate between polar coordinates and rectangular coordinates? Well, we have to use trig. So we know that if we have a right triangle here on our XY plane, and theta is, by the origin, as it usually would be, we've got an X, a Y, and an R. And in pre-calc, you learned that cosine is X over R, sine is Y over R, and tangent is Y over X. So if that's true, if we solve this for X, we would get R times cosine of theta, and Y would be R times sine of theta. And we also know that if we have the equation of a circle, x squared plus y squared equals r squared. But that really, to relate it to this, that could be kind of like our Pythagorean theorem, right? So if we solve for r equals, we would get plus or minus the square root of x squared plus y squared. Okay? So that's what we're working with here to try to translate this. So let's say we're converting this ordered pair to rectangular. So right now it's in polar form, and we got to switch it to rectangular form. So remember, this is a length of 2 units away from the origin at an angle of 5 pi over 6. Okay, so to change it into rectangular coordinates, the easiest way is to use these two equations up here. So we're going to have x equals r cosine theta, y equals r sine of theta. So we've got the r and the theta to plug in. So we've got 2 times cosine of 5 pi over 6 and 2 times sine of 5 pi over 6. That's going to be 2 times negative root 3 over 2, which will be negative root 3. And we got 2 times 1/2, or 1. So we've got the x and the y coordinates. So we've got negative root 3 comma 1. There's our ordered pair. And for the last one here, if this is currently in rectangular coordinates, remember when I'm trying to switch to polar, the best place to start is to find the r, and we can do that by doing x squared plus y squared equals r squared. And so we know 3 squared plus negative 3 squared is going to have to equal r squared. So we got 9 plus 9, or 18, equals r squared. So r equals the square root of 18, which is 3 root 2. I am not going to put plus or minus here because I want my r to be positive for our purposes. We'll just make sure that the angle is correct. And the next part is a little trickier, but in this question, all I want us to think about is that if we were plotting 3 comma negative 3, 3, negative 3, think about where that is. If we wanted this angle, it's halfway through quadrant 4, right? So if we think about our unit circle, that is going to be a theta of 7 pi over 4, right? We have 4 pi over 4, 6 pi over 4, 7 pi over 4. It'd be right there halfway between here and here. So that makes sense to me. We've got our theta, we've got our r, so our ordered pair is r comma theta. So we got 3 root 2 comma 7 pi over 4. And just to remind you what that means is that from here to here is a length of 3 root 2, and it's an angle of 7 pi over 4 to get to this point. But that's also represented in rectangular coordinates by the point 3 comma negative 3. All right? So if that doesn't make complete sense or it's not fully clicking at this point, that's okay. I just wanted to get those notes started. Now I am going to show you how you can put your calculator into polar coordinate mode. And that's going to be important for the worksheet that you're also going to be doing today. So if you pull out a graphing calculator and you go to y equals, currently it is in y equals mode, in rectangular mode. But if we go to mode we can switch this from function to polar. And then if we go to y equals, now you can see it's R1, R2. And polar equations are usually in the form R equals something with theta in it. And you'll notice if you press with the button next to alpha, that usually makes an X. Now it makes a theta. So that'll be useful. And what I want you to do for the worksheet is just try to roughly sketch several graphs using the calculator and see if you can find the trends. All right, so that's all you're going to be doing for the worksheet today. And if you don't have your own TI graphing calculator, you might have to do a little bit of research online if you're using Desmos or another type of graphing calculator to see exactly how to graph using polar coordinates and polar equations. But I bet you can figure it out. If you have any questions, let me know. And good luck with the worksheet. Thanks very much.